Hello Year 11. This question comes from the 2005 Extension 1 Preliminary Exam from James Ruse. It's question 3, part C. And I've had someone send through a request to help with specifically part 2 of this question. So there's 2 parts, part 1 and part 2. I'm only being asked to help with part 2, but I'll read through the whole question just for the background. We're told in an activity during a sport class, students are to run from position A to the fence surrounding a circular field of radius 60 meters and return to position B. Jason, who is a top maths student, decides to calculate which direction will give him the shortest path. And then we have this diagram here. Part 1 says if he runs from A to P, then to B, show that the total path length d meters is given by d equals 30 square root of 5 plus 4 cos theta plus 20 square root of 10 minus 6 cos theta, where angle POB is theta, and theta is between 0 and pi radians, or basically 0 and 180 degrees, or basically anything between a straight line. So part 1 we're going to take as given. You can get to that expression without too much effort using the cosine rule. First you'd use the cosine rule on triangle AOP, then you do a similar thing with triangle BOP, and without too much difficult rearranging, you will get to this expression. So I'm going to take that as given. If that is something you do need help with, please feel free to comment on this video asking for me to work through that, and I can happily make a separate video where I do go through that. But for this video, we're going to say that we've been able to get to the point where we can show this is the distance traveled. And just to clarify the way this setup is going, we're saying we're starting at point A, we're running over to point P, and then we're coming back to point B. And point P can be anywhere, basically anywhere in this semicircle here, because the angle of theta, which is defined as angle POB, basically angle POB, so this angle here is theta. That can be anywhere between 0 and pi radians, anywhere between 0 and 180 degrees, so basically these, anywhere between that line. So we're kind of dealing with the top half of this circle. We're being asked to find what angle theta would make that distance from A to P to B as small as possible. That's part 2. So part 2 says find the value of theta, which will give Jason the shortest path, justify your answer, and it's worth noting that this is a 5-mark question. That's a lot of marks in the context of an exam. So that justify your answer is going to be very important, because perhaps you may think about this intuitively, and I might talk about my intuition before I go through the algebra, the detail of this. But actually, before I even do that, something I wanted to do was to just test how AI would handle a question like this. So I've got Copilot here, and what I'm going to do is I'm just going to say, please answer this question for me. I think it's important to, please answer this question for me. Important to say please, because I, for one, welcome our new AI overlords, and I want them to be on my side, so I'm going to make sure I'm polite at all times. So I'm just dropping in a screenshot of the question. I'm going to press go, and at this point in time, at the date of recording, I'm very interested to see how AI does, because whilst it's rapidly advancing, I'm not sure it could handle something like this well yet. So naturally, it's doing both parts. For part 1, how's it going? Use coordinate geometry or vector analysis. Apply the law of cosines or the vector dot product. Yes. So I think applying the law of cosines is the simplest way. Oh, okay, and that's all it's done. So it hasn't actually done it, but it just said this is how you could do it. Okay, that's fair enough. Accept it as given. Okay, sure. Okay. You probably need to prompt a bit more if you actually needed help to do that, but that's not wrong. Okay, part 2, find the value of theta that minimizes d. So, yeah, we get a function of theta. I don't really know this syntax, but anyway, it says take the derivative, which is, again, what we're going to do. So it differentiates. It does a bit of a U substitution, which I don't know if that's necessary, but anyway. Okay, it says the minimum occurs at theta equals 0, which, as we're going to see, is not correct. So, yeah, not the best answer. I think it would need a bit more prompting. What I've noticed with AI at the moment is often it kind of spits out stuff that looks like it makes sense, but often it gets the wrong answer, and you need to tell it it's wrong and the way in which it's wrong before it can get to the right place, which naturally is fine if you already know how to do it, but if you genuinely couldn't have done this question, I don't think the AI is going to be much help right now. One day, sure, but today is not the day. So what we will do is work through this the old way. And as I mentioned, I'd like to start with just a little bit of intuition before I dive into the detail here, because notice that the expression for d has essentially cos theta is what's driving it. Everything else are basically constants. D is a function of theta, and in particular we've got cos theta. So it may be intuitive to think, well, wherever cos theta is minimized, that's where this function or this expression for d will be minimized. So what I might do, just to kick off before we dive into anything too detailed, all right, we're doing part 2. I'll just note this is an intuitive approach. This is not what will get the marks. But I would like to just first draw up, let's consider cos theta for the domain we're given, which is theta between 0 and pi radians. So that's an easy enough curve to sketch. So we'll go pi. That's probably all we need because we're only going up to pi. We'll have theta, that'll be pi on 2, that can be pi. We'll go from 1, 0 to -1, and hopefully you're very comfortable with the idea that the cos curve starts at 1, it comes down and hits 0 at pi on 2, and then keeps going, and it continues on, but we're only concerned up to pi. And I notice that the cos curve hits its minimum value in this domain at pi. So it would be fair enough to think perhaps pi is the value of theta that will make the distance the shortest. Now that interestingly that is the answer. That is the value of pi that will get you the shortest distance, but I'm not sure what I've just done there is enough of a justification to get all 5 marks. Go! So it is interesting, the intuition does turn out to be right, but the only problem with that intuition is just because theta equals pi minimizes the cosine, it doesn't necessarily mean it minimizes the whole expression, because notice we've got a plus 4 cos theta and a minus 6 cos theta, and you really need to think about how that's all interacting, because what if the minimum of the cosine becomes the maximum of this curve? It doesn't in this case, but it could. And so actually we need to be a bit more rigorous in our approach. And so what we need to do is use the classic steps of calculus to differentiate this function of theta, and then find out what values of the derivative, or what values of theta make the derivative 0, and then there's a few options about how to then work out is it a minimum or maximum, and I'll talk about those when we get to it. But first let's start by differentiating. So maybe I'll call this the rigorous approach. this is the one for the actual marks. So first we want to differentiate d. So I might just write d in a format that makes it a bit easier to differentiate. So d is equal to 30 times the square root, and I'm going to write that as a power of a half. So 5 plus 4 cos theta, and that's to the power of a half, plus 20, bracket, 10 minus 6 cos theta, and that's also to the power of a half because that's what a square root is. So now we'll just find d dash, the derivative, and I'm basically using the chain rule. So I'll have a half times the expression and then I subtract 1 from the power, and then I multiply by the derivative of what's inside, which would be the derivative of 5 plus 4 cos theta would be minus 4 sine theta. So hopefully you're familiar with how to differentiate cos and sine and all of the trig ratios. So that's the first part. Then we will do a similar thing for the second bit. So that will again be plus a half. I bring down the power. I multiply by what's there, noting to subtract 1 from the power. So a half minus 1 is negative half again. And then I multiply by what's on the inside. The derivative of 10 minus 6 cos theta would be plus or positive 6 sine theta. So we can clean this up a bit. We'll do a half times 30, 15 times minus 4. So that would be minus 60 sine theta times 5 plus 4 cos theta to the negative a half. And then a half times 20 is 10, 10 times, so we'll get plus 60 sine theta, and then we'll have 10 minus 6 cos theta, also to the negative a half. And I might just factorize out that 60 sine theta. And I might write the positive term first, so we'll have the 10 minus 6 cos theta to the power of a negative a half, 10 minus 6 cos theta to the power of a negative a half, minus the 5 plus 4 cos theta to the power of a negative a half. So that is the first derivative. Now, hopefully you've done enough calculus to know that the stationary points, or in other words the minimums, the maximums, the inflections, the stationary points occur when this derivative d dash is equal to 0. So basically we want to solve for when this derivative is 0, find those values of theta, and then determine which of those values gives us the shortest distance. So I might scroll down. So we'll say we want 60 sine theta times 10 minus 6 cos theta. Oh, that's a bit of a messy theta. So theta to the negative a half minus bracket 5 plus 4 cos theta to the negative a half. All of that needs to be equal to 0. So basically we can use the null factor law here to say for this whole thing to be 0, either this part will be 0 or this part will be 0, because 0 times anything is 0. So we can start with the first bit. Therefore we can conclude that 60 sine theta must be 0. So that means sine theta is 0. And the value of theta that would make sine theta equal to 0 in our domain would be 0, because sine 0 is 0, or pi, because sine of pi is also 0 for the domain we're working in. And so that's really important to remember. We have been given a specific domain. Okay, so that's the first part. Now we could also say it's also the case that 10 minus 6 cos theta to the negative a half minus 5 plus 4 cos theta to the negative a half. That also could be equal to 0. So let's clean this up. I can bring one of the items to the other side so that we'll have 10 minus 6 cos theta to the negative a half equals 5 plus 4 cos theta to the negative a half. And that negative a half power just means 1 over the square root. So I might just write that. So that's 1 over the square root of 10 minus 6 cos theta. And that is equal to 1 over the square root of 5 plus 4 cos theta. And I could take the reciprocal of both of these fractions. That's a valid move. So square root of 10 minus 6 cos theta would be equal to the square root of 5 plus 4 cos theta. I could then take the square of both sides, so 10 minus 6 cos theta is equal to 5 plus 4 cos theta. I will maybe add the 6 cos theta to both sides and then subtract the 5. So I'd end up with 5 equals 10 cos theta. Divide both sides by 10, and we're basically left with cos theta is equal to a half, and that would mean theta in the domain we're dealing with would be pi on 3, basic 60 degrees or pi on 3, and that's for the theta domain that we're given. Okay, so we have 3 possible answers for theta that will make the distance travelled the shortest, either 0 degrees, 0 degrees, pi or 180 degrees, and then pi on 3 or 60 degrees, or in radians, 0, pi, pi on 3. Now, I'm conscious that this question, I might just write that, therefore theta will be 0, pi on 3, or pi. Now, if you are a Year 12 student studying for the HSC, and you've learned everything there is to learn in both the Advanced and Extension 1 course, then your instinct would be to find the second derivative and work out whether it's positive, 0 or negative, to work out what type of stationary point that is. Just looking at this first derivative, the second derivative will be a bit messy to find. You're going to have to use product rule with chain rule in there. It won't be nice. So you may then, if you start to go down that rabbit hole, pull back and say, you know what, I'm just going to use the first derivative test. I'm going to test either side of each of these points and see whether the sign changes and how it changes, or whether it stays the same. And that could also tell you what type of turning point it is. But actually, I don't know if a Year 11 student at the end of Year 11 would have necessarily learned all of these techniques yet. And in any case, we don't really need to go down that rabbit hole, because here we have 3 potential values of theta. All we're trying to do is find out which of those values will give us the smallest distance travelled. And since there's only 3 of them, we can just substitute them all in. Just sub in each of those values and find out which one gives us the shortest distance. And as I've already hinted, we know that the answer will be pi. The AI incorrectly told us the answer was 0, so it wasn't like completely off the mark. It did the work to find one of these solutions. Maybe it did the work to find all of them. I couldn't really understand that output too well, quickly anyway, but it's clearly picked the wrong one. But all we need to do is just say, well, D, when theta equals 0, D is equal to what? And we just go and find our original expression for D, 30 times 5 plus 4 cos theta, or in other words, cos 0. So 30 times 5 plus 4 cos 0 to the power of a half. Well, it's the square root, but anyway, same thing. Plus 20, 10 minus 6 cos 0, plus 20 times 10 minus 6 cos 0 to the power of a half. And we just ask ourselves, well, what is that? And so we can go to our calculator and we can say, what is 30 times the square root of 5 plus 4 times cos 0, and then we're going to add 20 times the square root of 10 minus 6 times cos 0. We press equals and we get 130 meters. Okay, so when theta is 0, the distance traveled is 130 meters. When theta equals pi on 3, what is the distance? And actually, I should probably check that this this calculator is in radians mode. So we'll put it in 4 for radians. Unfortunately, I need to type all that again. But I might go shift pi divided by 3. And let's put that in storage, and now I can just use A. So we're going to have 30 times the square root of 5 plus 4 times cos of A, plus 20 times the square root of 10 minus 6 times cos of A. And we press equals, and we get 132.2875 and that's probably going on forever, meters. And clearly that's not the winner so far because that's more than 130. So 0 is currently the best option, but if theta is equal to pi, D is equal to what? And I'll just come in to what I'd already typed, and wherever I had A, I'm just going to replace that with pi now. So pi, and that just saves me from retyping it all. Pi equals 110. And there we go. So that is clearly the shortest of the 3 distances, 110. So we can conclude, therefore, the shortest distance occurs when theta equals pi radians. Now, that's the answer. So I'm pretty confident that showing what I've just done is what would get you the 5 marks. Exactly where those marks are allocated, I wouldn't want to guess. But you can see this rigorous approach, there is quite a lot going on. You'd definitely get a mark for differentiating. You'd probably get a mark for finding the stationary points. Maybe it's 1 mark for each, I'm not sure. You get your mark for then substituting, or maybe there were marks allocated for finding the next derivative or using the first derivative test. Maybe James Ruse accelerates their classes, and so by the end of year 11 they've learned all that. That wouldn't be completely out of the ordinary, given it's James Ruse. But in any case, you don't technically need to do any of that. I think just substituting in is valid enough. You find which one's the shortest. What I'd like to do is just come back up to the original diagram and just kind of clarify what's really going on here. So I might erase all of these highlights I did. And now that we know pi on 3 is not really a real contender. It was between 0 and pi. And if I think about what an angle POB being 0 really is, what that is I'm starting at A, and then I'm going to go this angle here. The way you would picture this angle being 0 is basically, if we're measuring the anti-clockwise direction, it's kind of 0 here. So I would be going from A over to P, which would be sitting here. So that would be 30 meters plus 60, which is 90. And then I would be coming back to B. So how can I highlight that? So we go from A over to P, and then we go from P back to B. So here we've gone 30 plus another 60 is 90, and then coming back to B, if this whole thing is 60 and this is 20, that means this bit must be 40, and 90 plus 40 is 130. So we see that when the angle theta is 0, actually without too much difficult calculation, we can get that 130. That's pretty clear to see, hopefully, intuitively. And now if I do the other option, the 180 degrees, so I'll erase all this, what that really means is this theta has come over 180 degrees. And so if I'm starting at point A, I go this distance to point P, which would now be there, and then I come back to point B. And so again, if this whole distance is 60, because that's the radius, that means this must be 30. So what I've travelled is 30, and then I come back 60, which is 90, and then I go another 20, which is 110. And that's quite a quick and easy way to get to the 110. So hopefully it all makes sense, those answers in the context of that diagram. Again, maybe a really good student could see that intuition. So I had a bit of intuition thinking about the cos curve, and maybe really the two extremes of the cos curve, when theta was 0 or when theta was pi, they were the two real contenders, and perhaps you could justify your answer starting from this point and then doing what I just did on the diagram to get those 5 marks, perhaps, without doing any calculus, maybe. But I have a feeling it's the calculus that the question writer was looking for. At least finding the stationary points, setting them to 0. Whether you then find the second derivative or use the first derivative test, I guess it depends on what you've learned at this point. But that's how you do that question. All right, tick boom.
Tick, tick.